of topic 4, equations and stoichiometry review. There are some notes that we went over in class, and these are how you work through the practice questions. So, which substance has the greatest molecular mass? Simply, you have to get the gram formula mass. All I did was go to the periodic table. I looked up the mass of hydrogen. There's 2 of them, so I multiplied that by the mass. So 2 times 1 is 2. Oxygen has a mass of 16. 2 of those, 2 times 16 is 32. 32 and 2 is 34. On the second one, nitrogen is 14, oxygen is 16, added those masses. On number 3, carbon is 12 and fluorine is 19, but there's 4 of them. And on the last one, there's 2 iodines. So you can see that iodine has the greatest molecular mass. In number 2, what is the gram formula mass of CaOH2? Remember to distribute the 2 across the parentheses. So you have 1 Ca, 2 O's, and 2 hydrogens. You can see my math off to the right there. I took the number of atoms, multiplied it by the mass, and then added it up to get 74. In 3, what is the total number of moles of atoms? So when we talk about moles, there's 2 things to consider. We know how to calculate moles using the given mass and the gram formula mass, but when we look at a balanced equation, okay, the coefficients in front of the substances also refer to moles. And when we look at a formula, so when we look at Pb or lead 2 acetate here, we can see that there's 1 mole of lead. We distribute that 2 across everything in the parentheses, so there's actually 4 moles of carbon. There's actually 2 times 3, 6 moles of hydrogen, and 2 times 2, 4 moles of oxygen. And you can see to the right there, I did my work and I added all my moles to get 15. Percent by mass of carbon in acetic acid. Remember, this formula is on the back of your reference tables, table T, so you should be looking at that. Percent by mass is part over whole. So I circled my part. My part is my carbon, and there's 2 of them. And my whole is the whole compound, the acetic acid. So I figured my carbon first. 2 times 12 is 24. And then I figured I have 4 H's and 2 O's. So I got that mass, which was 36, added the 24 to it to get my whole. So my part is 24, my whole is 60. And that's times 100. Remember, empirical means reduced or simplified. So 3 goes into 3 once, and 3 goes into 6 twice. So I get an empirical formula of CH2. Naming compounds. If you have more than 2 elements in a compound, meaning that it's ternary, not binary. Binary means 2. If you see more than 2 different elements in a compound, you're dealing with a polyatomic ion, which means that you have to use table E. So if you find ClO2 on table E, you'll see it is chlorite. So they told you the potassium part already, so if we put the whole thing together, it would be potassium chlorite. What is the correct formula for ammonium sulfate? Both of these are polyatomic ions. Again, you're looking in table E. There is no ammonia element on the periodic table. Okay, ammonia, NH3, or ammonium, NH4+. Okay, they aren't on the periodic table. Ammonium is an ion. Ammonia is a compound. So we're going to go look up both polyatomic ions. You see I wrote them off to the right there. I also wrote their charges, which are found in table E. And then I dropped and crossed. So I got 2 for my answer. 8. The molecular formula of a compound is represented by X3Y6. What is the empirical? So I'm just going to reduce that again. 3 goes into 3 once. 3 goes into 6 twice, so I get choice 2. If I'm going too fast, feel free to pause me at any time so that you can write notes or catch up. 9. The number of moles of molecules in a 12-gram sample of Cl2. So we are using stoichiometry now. In order to change mole to moles, you need to know the gram formula mass. We just recently did this, calculated moles on the popcorn activity. So Cl2 has a mass of 35.5, but there's 2 of them, so I have to multiply it by 2. I get 71. So you can see my dimensional analysis there, 12 grams, and we know 1 mole equals 71 grams. My grams cancel. So 12 divided by 71 is my answer. What is the total number of moles of sulfur atoms in a mole of Fe2SO43? So that's iron 3 sulfate. Remember that 3 gets distributed, so 3 times 1, there's 3 moles of sulfur atoms. All right, moving up. Given the unbalanced equation. So I'm going to tell you how I balanced this. All right. I first looked and I saw that Ca appears once on both sides. The SO4 appears once on the left and 3 times on the right. So what I did was I put a 3 in front of the CaSO4 on the left. That then gave me 3 SO4s, but it also changed my CAs. I now have 3 CAs. So then I went to the right and put a 3 in front of CaCl2. Now my CAs are balanced, but it gave me 6 chlorines. 3 times 2 gave me 6 chlorines. So now I have to come over here to AlCl3 and put a 2 in front of it. So 2 times 3 is now 6 chlorines. That also gave me 2 aluminums, but I already had 2 aluminums in the Al2SO43, so I didn't have to do anything. And they want to know the coefficient in front of the aluminum sulfate. It's 1, because we never usually write 1. You can write 1, we will not write it wrong. Do not write 0. Okay? Never ever write 0 in a balanced equation. All right, moving down to 12. We also had a balance here. This is really important. Notice I've got arrows going from O2 to the O3 and Al2O3. Whenever you have an uneven number, you always want to take care of that first. And the best way to take care of that is find the least common multiple. So the least common multiple between those 2 digits is going to be 6. So how do I get 6 oxygens? Well, I'm going to put a 3 in front of the O2 because 3 times 2 is 6. And I'm going to put a 2 in front of the Al2O3 because 2 times 3 is 6. That then changes my aluminums to 4, 2 times 2. Ooh, and I made a mistake there. I need to have a 4 here. Good thing I'm talking this out. See, even adults make mistakes. So this right here should be a, it's going to let me draw, maybe? Here we go. This should be a 4. Okay. That should be a 4. So if you're watching this, make sure that you correct that. So that means, that doesn't change my answer though. There's still a 3 in front of the O2. All right, moving on. What is the total number of moles of NO produced? Notice I put an X over that. When 1 mole of oxygen is completely consumed. So what I'm doing is I am setting up a proportion with what I'm given with what's in the balanced equation. So see how I pulled them out over here? I put 1 over 5 equals x over 4, and then I just cross multiplied and divided. 5x equals 4, divide both sides by 5, and I get x equal, oh, I got cut off over here. This should say 0.8. And that was my answer. Okay. Moving on. 14. What's the total number of moles of HCl? So I put an X over HCl when 3 moles of H2 is produced. Again, all I did was set up a proportion. 3 over 1, because there's an unspoken 1 in front of the H2, equals X over 2. Cross multiply and divide, and X equals 6. All right. Which equation shows a conservation of atoms? Conservation means balanced. So you're looking from the left to the right side of the equation. So I have in choice 3, 4 H's on the left and 2 times 2, 4 H's on the right. I have 2 O's on the left and 2 times 1, 2 O's on the right. You can see that the oxygens are not balanced in choice 1. I have 2 on the left and 1 on the right. You can see that the hydrogens aren't balanced in choice 2. I have 2 on the left and 4 on the right. And in choice 4, the oxygens aren't balanced. I have 4 oxygens on the left and 2 on the right. In number 2, which substance can be broken down by a chemical change? Something that can be broken down. You're looking for a compound. Notice how I marked 1, 2, and 4 are found on the periodic table. Those are elements. They cannot be broken down. Hexane, even though you don't know what it is, cannot be found in your element list on table S. In choice 3, question 3, what is the gram formula mass of Ca3PO42, calcium phosphate? I have 3 calciums times the mass of 40, 2 potassiums times the mass of 31, and I have 4 times 2, 16, 8 oxygens times the mass of 16. I get those, add them all up, you see my math there, and I get 310. In number 4, what's the ratio of metal ions to nonmetal ions? In which compound? Is it 1 to 2? So I actually had to figure out the formulas for all of these. Calcium's plus 2, bromine is minus 1, drop and cross, and I get CaBr2. That's my answer. But continuing on, calcium oxide, plus 2, minus 2. Whenever you have equal and opposite charges, it reduces to a 1-to-1 ratio. Calcium phosphide, plus 2, and phosphorus is minus 3. That gives me Ca3P2. And in calcium sulfide, plus 2, minus 2, again, 1-to-1. In question 5, what is the mole ratio of CO, carbon monoxide, to CO2, carbon dioxide? You can see that it's 2 to 2, and 2 to 2 is the same as 1 to 1. Okay, I'm going to end that video here, and I'll continue on the next one.